Eduardo Penabad is now going to provide an overview of the forecast products available on the climate data store of C3S, of the Copernicus Climate Change Service, and also the graphical products. So Edu, the floor is yours.
Thank you very much, Chris. Good morning, everyone, and thanks also to OACPS and the ClimSA initiative to having us today here to introduce what we are doing at the Copernicus Climate Change Service in regards to seasonal forecast. So let me try to start sharing my slides. I hope you can see them. The first slide there with the title.
Yeah, we can see it fine.
Perfect. So if you I will start with as Chris said, what I'm going to introduce you is just an overview of what you can find at the C3S, at the Copernicus Climate Change Service in terms of seasonal forecast products. And the overview is quite simple. So if you remember last slide that Anka has just shown you, which I have done a screenshot here on the right, she spent a couple of minutes going over that. I will spend close to half an hour to expand a bit on all the elements that were there. So essentially, this talk would be split in two parts. The first one, where I will expand on the two bits that we have in that slide about the products available as data, as files or data that users can download and then make use of them, and products that are based on graphical elements, on plots, on maps, on time series, both about the real-time forecast and also in terms of verification. That would be the first half of my talk, and the half would be to try to show you on a live demo how all this works in reality. So the first link that every time that you see one of these wobbly boxes with a URL link that will contain a URL link, and this is the main one that it takes you to the C3S web page, and specifically to the section about seasonal forecast, where you have links to both areas, to the climate data store with the data and to the graphical products. But we will see that in more detail later. So let's start with the products, and start with the first bit about the products, which is the data. But I've been using this acronym CDS, and maybe you are not familiar with it. The Climate Data Store, shortened as CDS, is the main infrastructure behind the service, the Copernicus Climate Change Service. So it's a platform where you have a data catalog, which currently consists of more than 120 different data sets, from in situ observations, reanalysis, to climate predictions, both seasonal timescales and in the future. There's already some demonstrators there about decadal timescales. There will be more in the future, and also climate projections. So all those data and derived data sets from all these families of data sets. All these data sets, I've used data sets in quotes there because it's a bit not well defined. By data set in the context of a climate data store, I mean one entry in the CDS catalog, something that it has an independent entity within the data catalog in the CDS. That's what I'm calling here a data set. And the climate data store is not only that. It's not only the access to the data sets. It has also some tools, a reduced list of web applications so far that will be expanded in the future. Some tools for the users that are starting to come. The climate data store went through a modernization in the last couple of years, and there are still some new elements that are appearing, and one of them is the Jupyter Hub. But and there's also a component of user support that I will also talk about a bit later in this talk. So that you have the URL to connect directly to this platform, to the CDS. And later in this talk, I will focus a bit on how to access to the data, both with looking at the interactive forms in the CDS and the interface to use that as with a programmatic view. So I will talk about later about those two ways to access the data, and my colleague Chris Goddard will come also later this afternoon to show you a bit how to work with one example of those tools that will be the Jupyter Hub. But you will hear more about that in the next during today. So if we look a bit at back here to the main entrance point of the CDS, of the climate data store, you will see that there are, you cannot read probably what says there, but you have a search bar there. You can introduce any search keyword there, and it will show you the datasets related. And there's also a link to datasets up here. And that's what I'm showing in the next slide. If you click on that datasets section of the CDS, you will end up here. You will still have a search facility, but you have some filters on the left. And the datasets, as I said before, by datasets here, I mean entries in this CDS data catalog. The datasets I will talk about today are the ones that you will select if you filter by seasonal forecast and global. So there are some other entries in this catalog that has data from seasonal forecasts, but the ones that I'm talking about are the ones in this context of the C3S activity that Anka introduced before, this multi-system C3S seasonal forecast activity. And when you do this filtering, you end up seeing 7 different datasets, the ones that I'm listing here. I did a bit of color coding here because you can start to see some patterns there. Look like there are some clusters there, some clustering about daily and sub-daily data, and then divided in single levels and pressure levels data. Another cluster about monthly statistics when we have the single levels, pressure levels, and ocean variables, and the same thing about anomalies. This more or less maps onto what Anka already introduced before. And I've kept the infographics with the 9 forecast system, with the 9 institutions contributing with their forecast systems here, because what I wanted to highlight is that the data available in these data sets is the data from all these individual forecast systems. That's what you will have there, the data in all these different flavors from this the forecast systems from those institutions. And as you can see, essentially what we have there is the data in the higher frequency. Then from that data, we produce some monthly statistics, monthly means, monthly minimum and maximum. And from those monthly statistics, we pre-compute some first order bias corrected post-process products that are simply anomalies for all the individual members and for the ensemble. That's essentially a summary of all the data that it's available on the CDS. And as Anka introduced before, there are 2 types, or there are 2 subfamilies of data within this. They are not distinguished like that in all the cases, but you will have real-time forecasts that are published every month. And so we have just published last week the real-time forecast that we labeled as June 2025. And as Anka said, the data from ECMWF seasonal forecast is available on the CDS on the 6th of every month, and the data coming from all the other providers on the 10th of the month. Regarding the reforecast or hindcasts, some of them are produced on the fly. We have one forecast system, the Metoffice Glossy 6 at the moment, that produces the hindcast on the fly. That means that they are produced every time a new forecast is going to be released, a few weeks before they are produced. And for the rest of the systems, they are produced on a fixed data set. But in some cases, when we have a new system recently introduced, they don't appear all of them at the same time on the CDS, so they will appear one after the other. And the quality of service that we aim to have is that at least 1 month before they are needed, those hindcasts are ready for the users to download them and start doing their processing or whatever downstream workflows they need to run with them. Moving forward a bit more closely to what's in each one of those families of datasets, I have also added, if you can see here in gray, some slugs that's part of the short names of the datasets used both in the CDS URL and in the CDS API. We will get to the API in a minute, but this is so to speak, the name that summarizes each family of datasets. As I said before, we have the daily and sub-daily data, the high-frequency data, then monthly, and then anomalies. Both in the daily and sub-daily data, we have data for the real-time forecast updated every month, and we have the data for the hindcast. At the very least, for each individual system, we have reforecast data, hindcast data for the period between 1993 and 2016. Those dates are not exactly the same for all the systems. Some of them have some early years, some of them have more recent years. But at the very least, all of them have hindcast spanning that period, which is the one that we are currently using for all the products, for the anomalies and for all the graphical products. In the daily data, you will have frequencies of some variables at every 6 hours, and most of them every 24 hours, daily variables. That's for the variables that are at single levels. That's near the surface, that at the top of the atmosphere. That's in the integrated variables in the whole column. Or also currently we have added in the recently we have added in the single level data sets also the soil temperature at the different the soil moisture at the different soil levels solved by each one of the forecast systems. We also have a set of I think it's 13 pressure levels from close to the surface up to the stratosphere, and the variables are, there are 5 variables there which are made available every 12 hours. Exactly the same list of variables that we are listing here. That's essentially the raw data. So ignore for a minute this column about the start dates. And in this family of daily and sub-daily dataset, we have raw data. It's essentially what we receive from the C3S contributors. We simply convert that to the same format to put it in at ECMWF Mars archive. That's in GRIP format. And that's the data as we receive it. Then we an almost raw data in the sense that it's uncorrected, that it's only some time aggregation performed. That's the monthly statistics I mentioned before. That's done for all the variables that we have in the daily, in that original data sets. And then from that monthly, we produce a first set of post-processed of products that are the anomalies with respect to that period, 1993 to 2016, of each one of the model climates. Regarding this hindcast period, as I said, there are minor differences across forecast systems, and with the introduction of new systems in the last few months and in the near future, we will be moving. We don't have yet a clear timeline for that, but it will happen in the next couple of years. We will be moving the baseline period to closer to real time, because as you can imagine, in the context of the climate change trends, having a closer to reality period makes things much more relevant to reality. So as I said, and this is the anomalies data set is the only one where there's some sort of bias correction. Is by design we have removed here the mean bias from the forecast by simply comparing them to their own model climate. So no observations are involved. That's what I meant. No observations are involved in that bias correction. And that's a summary of those data sets. As I said, let's focus for a minute in this start date business, because that's relevant in how the data is structured. We have 2 families of forecast systems. Some of them they map the uncertainty in the initial conditions by running a burst of ensemble members starting on the same date, typically on the 1st of the month. And that's what you will see in the first line here. But we have also a few models that in order to sample the uncertainty in the initial conditions, they start few members, but on a different on different start dates. Usually, if we take as a reference the 1st of the month, on some dates in the previous month. So there's a concept that we use, and that it's used, as I said before, if you can see here, it's different for the monthly data sets than for the daily and sub-daily data set. In the daily data sets, we use the original start date to label the data. When we got to monthly time scales, we use what we call the nominal start dates, and I will get back to that. So for a burst start system that's clear, it will be the 1st of the month M here, and for a lagged start system, what we call the nominal start date, it will be all the dates on the 1st of month M and on all available start dates in the previous month. That also has a bearing in the way data is accessed in the data store, because when it gets to monthly data, you will need to specify the lead time in months. And the convention we use there is that the first month, it can sound a bit counterintuitive, but that's the way it's labeled in the data. The first month, the month of the initialization, is labeled as month 1, and so on and so forth. That would allow us, we don't do it, but would allow us to compute partial monthly means with the data with incomplete months and label them with month 0. As I said, we are not doing that, but that's one of the reasons behind this numbering starting in 1, which might be confusing to some users the first time they get into that. Let's move quickly to the last bit about the data products. Probably, as you can start to see, and it's a complicated set of data sets. There might be a lot of questions, and there are a few ways where users can get help if they need to get help. The main point of help should be the documentation. We have it's probably suboptimal in some aspects, but there's a lot of information there that it's valid, and it answers the sort of questions that I have put examples there, whether certain variables available for a certain system, whether what systems were in operations at a given date, when do I have available the hindcast data for a given system, if I need to find some information about how the products are created, for instance, what's the reference period for anomalies, some characteristics of the forecast systems, like I exemplified that with the vertical levels in one specific system. There are also some known issues that we have identified and documented. That's also included in the documentation. And there's also in the documentation the bits about the verification. So you will have some first order information about the skill of the forecast systems there. So that should be, and I will show you later where this is, that should be your first point of access, the dataset documentations. But there are 3 other elements that you can use. There's a virtual assistant. Let me just move to so more on this documentation during the demo part. And about the other 3 elements, there's this virtual assistant, the C3S DAC, which is essentially a chatbot with all the positives and the negatives that has being a chatbot. So it can answer some simple questions. It can guide you to find some documentation or some data sets, but it's quite limited in its scope. There's a user forum, and this is a peer-to-peer support in the sense that any user can ask answers there, and many other users that are familiar will happily answer them or contribute. But there's also some ECMWF staff, for instance, both myself and Chris Goddard are monitoring the questions about seasonal forecast and climate predictions and projections in general there. So you will have sometimes some support directly from ECMWF staff. But if the questions are more complicated and they deserve a more dedicated support, there's also a dedicated support portal there that you can access, and it will create a ticket with the ECMWF user support colleagues, and it will be escalated to any other ECMWF staff needed. Or in the case of seasonal forecast, if it's about some specifics of one of the forecast systems, it will eventually get to the developers or to the producers of that data. So that's the summary about the products. Then moving to the second bit on the first part is still about products, but now graphical products. And here I will be talking about 2 families of graphical products, the real-time forecasts and the verification. You have the URLs to get access to each one of them. And let's move quickly to the graphical products. So regarding the release dates, all the graphical products, the real-time forecasts, are released on the 10th of the month, including ECMWF. Even though the data is released slightly earlier, the graphical products are released, all of them at the same time, and they also include some multimodal combination. So while the data, it's only about individual forecast systems, in the graphical products, we have a multi-system combination with all the contributing producing centers to C3S. And regarding the verification products, they are made available right after the corresponding hindcasts are available on the CTS. Going to the graphical products, if you go to that URL, you will immediately see this. I have obscure the right-hand side bit here, but in the left-hand side, you will see this filtering bit, which has 3 sections. One that allows you to select the reduced set of variables that we have graphical products for. One that allows you to select the type of plot. Essentially, that's spatial maps or time series. And in respect of the spatial maps, we will have 1-month aggregations and 3-month aggregations. And it allows you to filter by the producing center, either the C3S multi-system combination or each one of the individual systems. Let's play with some of the possible combinations. So if we select 2-meter temperature, 3-month maps, and the C3S multimodal, the kind of product that you will see are the ones that are expanded here. So you will have a summary of the probabilities in tercile of the forecast being in each one of the tercile categories. So essentially, this plot is a summary of the next three, which are the probabilities of being in the lower category, in the lower tercile category, in the middle tercile category, and in the upper tercile category. So all these four plots are related. The first one is a summary of the other three, but you can have access to the three of them, to all of them individually. Similarly, we have the probabilities of being in the extreme quintile categories, the upper 80, the lower 20%, and the upper 80%. A similar product is the probability of being on the upper half of the distribution, that's to be above the median. And there's also some sort of deterministic view on the forecast, which is the ensemble mean anomaly, which many users are familiar with and used to look at. So these are the kind of plots that we will see for most of the variables. And also you will I have selected here Africa, but you have a set of predefined regions where you can see the plots immediately. There's a variable that is slightly different. That's the sea ice concentration, and then I'm showing here. That's available both for the Arctic and the Antarctic Ocean, as I'm showing here, and there are three different products there. The spaghetti plot about the sea ice edge, the probability of being the sea ice concentration being above 15%, a value of 15%, which is what we have used more to define the edge of the ice shelf, and the anomalies, the comparison of the given forecast, the sea ice concentration forecast with its respective model climate. And there's also information about the ERA 5, an observational reference data set there on top of the reference for the real-time forecast and the model climate. So that's for sea ice concentration. If we move from spatial maps to time series, we have two types of time series, one related to SST indices, and that's the one that I'm showing you here for the multimodal again. And this is, we have for time series, we have three times of, for SST indices time series, we have three times of plots. One is all the individual models, all the individual members, either for the individual system or for the multimodal combination, as you can see here. Then there's a plot that shows us the probabilities of being in the extreme quartile probabilities and the center interquartile values. That is the probabilities of being in the above the 75 percentile, below the 25 percentile, and between the two of them. That for ENSO-related indices maps quite well, especially around the peak season of ENSO, maps quite well in what we can map to El Niño and La Niña events. But they are not directly El Niño and La Niña events. And you have also the reference, which is quite easy here. It will be 50% for the neutral, so to speak, categories, and 25% for each one of the extreme categories. And we have also a summary where we show the distribution of each one of the individual systems, and by the distribution I mean here the percentiles, the interquartile range, the median, and some extreme percentiles, the 10% and the 90% for each one of the individual systems in this multi-model view, and it will be only the individual systems in each one of the if you select an individual system. So that's about time series of SST indices. We also have, and as I said, you have that for the ENSO-related regions in the tropical Pacific, but we also have that for the Indian Ocean dipole, where we spell out not only the index, the Indian Ocean dipole, as the different in the anomalies of the western and the eastern pole of the index, but also the values for each one of the regions, the western and the eastern side poles of the Indian Ocean dipole. Moving to another type of time series that it's usually relevant in the boreal winter, it's the zonal mean of the zonal wind in the stratosphere, specifically at 10 hectopascals. We plot there in blue all the individual members, in shades of yellow or orange the model climate, and in black the reference, the observational reference, which is here ERA 5. And we have two views there. That's the time series of the raw data directly from each one of the models, and we also have a probability of the stratospheric vortex having been reversed. That means that the zonal wind velocity has turned into negative values, so that the polar vortex has reversed more. And you can see the probability, how many members are below zero compared to what happens in the climate, in the model climate. And we have the same for both the northern hemisphere and the southern hemisphere. And yeah, let's go directly to the live demo, because I have only left 5 minutes, and I will show you some of these bits directly there. The last bit, it was about verification. The other bit about graphical products is verifications, where you have some information for each one of the forecast systems, and for the multimodal, you have all star dates, all available star dates there, nominal star dates for all the 12 months from January to December. You have different aggregations for 1 month aggregations or 3 month aggregations, and you have a subset of variables and a subset of scores that are showed here as spelled out there, but you will see that when you browse yourselves the verification plot. So let's go to the demo in these last 5 minutes. I first wanted to remind you that as a user, my recommendation, it would be that your first point should be to look at the documentation. In each one of the datasets in the CDS, you will have a set of documentation pages that are reproduced from the Copernicus knowledge base. Essentially, there's one about announcements, one about generalities of seasonal forecasts in the line of what Anka introduced before, a description of the C3S multisystem. That's the characteristics of all the currently operational systems, and the description, the individual description of each one of them. There's a guide on how to use the CDS interactive forms and the CDS API, what means each widget, each element in the API. There's a summary of what data is available in terms of which dates for which system. There's a list of variables available for each one of the forecast systems in this detailed list of parameters. Some recommendations on how to best build your requests. Excuse me. A description of some known issues. Another page that it's a recent addition, and it's a quite important one. It's a description of all the products. Here is where you will find a detailed description on how both the data products and the graphical products are created in terms of methodologies and things like that. And there's the link to the verification plots. So I now have left 4 minutes to the live demo. Let's try to do that, at least a bit of that. So let me stop sharing the PowerPoint and move to share my browser, which should be this one. I hope you can still see my browser now. So as I said before, the starting point can be the C3S webpage, climate.copernicus.eu, and I'll show you quickly how to navigate to find the seasonal forecast. So you go about, sorry, not here. What we do, climate datasets, then you will find immediately seasonal forecast. And from this page, which is climate.copernicus.eu/seasonal forecast, you will have access to both the graphical products and the digital products, which is the access to the CDS. So if we go to the CDS, you will need to first register. By doing that, you will need to register creating an ECMWF user in the ECMWF web. Once you have done that, and it should work in my case, if I simply click login there, it shows my name. And if you go to your user in your profile, you will have access to your user ID and your password and your API token that you will need to do programmatically access the datasets. But let's go back to the previous view. And if we go to datasets, as I said before, if I select seasonal forecasts and spatial coverage global, I have the 7 datasets I've introduced earlier today. So if, for instance, if we go to monthly statistics, you will have in the overview a description of what variables are available there. And yeah, there's a longer list here. And if you go to the download bit, you can select whatever you want. So for instance, let's go for the the Met Office, the most current system. There are explanations about what the systems from the ECM for the Met Office mean, because there's some explanation that needs to be done in why we are using these funny numbers. And if, for instance, we want to download 2-meter temperature and total precipitation, we can have the monthly mean for all the individual members, and we go to, for instance, we want to download the hindcast, and let's start just with one of them, one of the years in the hindcast period. Let's go with the current one, June, and all lead time months. So that means these year and month are for the start date, lead time month are for the forecast dimension. And then if we it will give us the option to download the data in GRIP. That's the recommended option. There's a conversion to NetCDF. This is considered experimental, and some changes in the names and in the structure have occurred in the past, and they can happen in the future. So our recommendation would be that for operational purposes to always download the GRIP format. But a NetCDF version is available there in case that it's useful. So the first time you use it, you will need to accept these terms of use and license to use the Copernicus product. If not, it wouldn't allow you to do the download. And it would be as simple as that. Once you have selected everything, you can submit your form. And if I go to my requests, it will appear there. It will appear the previous request that I have done. I will even be able to re-download the data that I have requested. And this now is showing me that the request is queued. Eventually, if the queue is generous with us today, it should finish more or less quickly. But if we go back to the request, and I can do that here, I can open this specific request that I've just made. You will have also access to the code of the API. And there's documentation linked there about the API that will tell you how to use the API, but that means that you can programmatically get access to this data using a Python script as it's described here. And I think that I'm running out of time. I will only extend my presentation for a couple of minutes. If I'm allowed to show you the charts. This is the interface I showed you before for the charts, and I want to only highlight two features that I think are quite useful. So if we go again, for instance, for precipitation, 3-time months, and the multi-system, this takes me there. And the first feature that I would like to highlight is these overviews. For instance, if you want to go look at all the forecast times, you will have it here. It will expand that. You can change that here if you want to have it a bit bigger, plots, and you can change the region that you would like to look at. For instance, let's go to the Pacific. And and then, yeah, you can do this kind of overview, and it will change all the plots in a coordinate fashion. The other thing that I wanted to highlight to you is the chart sets. So imagine that you want to compare all the different models of the 3-month maps of, let's select a different variable for this time, for instance, circulation, mean sea level pressure. And then we add all of them.
Edu, could you please select the sea ice?
Of course I can.
Somebody asked in the chat a question about sea ice.
Okay, let's add sea ice. So make clear. And now that I have sea ice, as you can imagine, I haven't been paying attention to the chat. So we add all of them in the same place. Now we can open this chart set, and let's move to the 3 columns. Then we have a nice view of all of them together, side by side. And we can change the product. For instance, if we're going to go to the ensemble mean anomaly, it will show exactly the same in the same configuration. So those are two nice features of this charts viewer. And last but not least, every time you go to a plot, you have the option to share it, to get some code to embed it in HTML code, or to post it in social media, but also to download the data as a static image, as a PDF file. And also you have the access to a script that would allow you to programmatically download the data every time. So you don't need to use the human interface. You can use a programmatic interface to download to get access to the plots in an automatic way. And that's sorry about having run over. That was all from my side. Thank you very much. And
that's great. Thank you very much, Edu. Oh,
Yeah, you said there was a question in.
yes. So there were several questions in the chat, but most of them have been answered. In fact, they've all been answered. So there was a question really about criteria-related variables. Yes, we have them. Anka listed the variables in the chat, not just CIs, but also other ones. There was a question about multimodal ensemble products. Yes, they're also available in the case of graphical products, and there's also the recipe to create these. And then there's a question about, does this recipe allow users to select products from specific centers among the 9? Chris Goddard will address this in his presentation this afternoon. There's also a question about multimodal ensemble verification. Can this be performed for a user-defined domain? Again, Chris will show that this afternoon. There's also a question about the Jupyter session, whether Python Jupyter Notebook, whether anything needs to be installed in preparation of this session. So because the time is relatively short, it'll be more in the form of a demonstration, but users can, of course, follow along if they choose to, or you can the Jupyter Notebooks are completely open source and accessible afterwards, so you can maybe follow and pay attention to Chris Goddard, and then afterwards you can explore them in your own time. They're very well documented. They can be modified to your own interests. If you do want to follow along, you can use some free cloud providers, which you just need to access, and then open the notebooks in these free providers. And we can provide some suggestions, I think, in the chat. In addition to those questions, I don't know if there are any other. Okay, there's a question from Hussein Said. Are the verification products based on real-time forecasts or hindcast data?
Yeah, the verification products are meant to be relevant for all the products, for the graphical products and for the post-process, the products like the anomalies. And based on that, they are based on the hindcast on the same period, 1993 to 2016.
Great. Anka, I see you have a hand up. I don't know if that's something you'd like. Yeah.
Yes, it is. I've just managed to type almost everything in the chat, thinking you weren't going to let me speak. Just to add something to the end of Eduardo's presentation, when he showed people those pictures and he said you can download the data, people might have got excited that they can get the numbers behind the pictures. That's not what he meant. He meant you can get the image files downloaded either programmatically or manually as PostScript or PDF. The data in the pictures, though, we are working on making that available to people. So that's probably going to be of interest to some. In a few months' time, we will announce this publication. And by the way, in the documentations of the Climate Data Store catalog entries, you will find a particularly important section, which is about announcements. Keep an eye on that if you want to use this data set, because there we tell people what's coming up. We tell people what we might have found wrong with data. So that's a really important item in a list of documentation items. Thank you.